Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 7, Why Trigonometric Functions Are Well Defined. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. What do I mean by well defined? Well, let's get into it. In the previous video, we defined the 6 trigonometric functions of an angle theta, or in a previous video. We define the 6 trigonometric functions of an angle theta in standard position. If the point x comma y is on the terminal side of theta, and that point is not the origin, and r is the square root of x squared plus y squared, the distance from the origin to x comma y, then here's the definitions of our 6 trig functions, which you need to know. However, the terminal side of theta has an infinite number of points on it, and this raises the question. If we pick a different point on the terminal side, we will get the same values for each function. Interesting. In other words, are our definitions of the 6 trigonometric functions well defined? Well, to answer this, let's examine an angle theta and choose 2 different points on its terminal side. We will name those points P with coordinates x, y, and P prime with coordinates x prime and y prime. Let Q and Q prime be the projections of points P and P prime onto the x-axis. In other words, the points on the x-axis immediately below P and P prime. We're going to let R be the distance from O to P, R prime be the distance from O to P prime, and the next 4, we're not letting them be. They're just a consequence of how we wrote the coordinates for P and P prime. X is the distance from O to Q. X prime is the distance from O to Q prime. Y is the distance from Q to P. And Y prime is the distance from Q prime to P prime. We're setting up representing the sides of 2 similar triangles. Let's separate the triangles, OPQ and OP prime Q prime, so they're not overlapping. On the left, we have triangle OPQ, and on the right, we have triangle OP prime Q prime. Now, it's clear that the red angle and the green angle are congruent, angle POQ and angle P prime OQ prime, since both have a measure of theta. Also, angle OQP on the left and angle OQ prime P prime on the right are congruent because they're both right angles, so they're both 90 degrees. And since the 2 triangles have 2 pairs of congruent angles, we can conclude the triangles are similar. Triangle POQ is similar to triangle P prime OQ prime. Now, since the triangles are similar, ratios of corresponding sides are equal. For example, if we took the ratio of PQ over OQ in the red triangle, it would equal the ratio of P prime Q prime over OQ prime on the green triangle. Normally, when we form these ratios, we pick one value from the left compared to the corresponding value on the right, but we can also form ratios within an individual triangle and form the similar ratio in the other triangle. Now, why these 2 ratios? Well, notice that in triangle POQ, the one on the left, the tangent of theta is y over x, which is PQ over OQ. But in the other triangle, tangent of theta is y prime over x prime, which is P prime Q prime over OQ prime. But the red ratio and the green ratio are equal to each other. We said that back here. And because they're equal, that means the value of tangent theta is the same regardless of which point on the terminal side we selected. Because again, on the red triangle, tangent of theta was PQ over OQ, and on the green one, it was P prime Q prime over OQ prime. But those 2 fractions were equal because of similar triangles. So tangent is well defined. It does not matter which point we pick on the terminal side. For any point x comma y on the terminal side of theta, tangent of theta is equal to y over x. And we can perform the exact same argument with all the other trig functions. For sine of theta, it would be y over r or y prime over r prime, which are equal because of similar triangles. For cosine, x over r compared to x prime over r prime, again, equal because of similar triangles. Cosecant being the reciprocal of sine would be y over r versus y prime over r prime, equal due to similar triangles. For secant, r over x versus r prime over x prime, again, equal because of similar triangles. And lastly, for cotangent, x over y or x prime over y prime, equal because of similar triangles. Therefore, the definitions of all 6 trig functions are well defined regardless of which point on the terminal side is chosen. There are no exercises to practice here.